Hey folks, it's me, Miss Rogers, and once again we're talking about parallel lines, and this time we're throwing in equations. So I've got a pair of parallel lines cut by a transversal, and I can tell that they're parallel lines because this little indicator right here kind of messed up on that one, and this one right here. Those little arrows on the two lines indicate they are parallel. So let's start off. It says if angle 4, if this angle right here equals 2x minus 17, and angle 1 equals 85. Angle 1 is right here. Find x. Well, I'm going to use this picture again, so I'm going to grab a pencil. Okay, so angle 4 is 2x minus 17. Angle 1 is 85. How in the heck are we going to do this? Well, we have to think about our angle relationships. That was the last video I made. We have to remember those angle relationships. So there's a couple ways we can go about this. We can find out what's complementary and what's supplementary, or we can find same side. I don't know what I'm trying to say. We can find corresponding angles that might work, or we can find vertical angles and find same side interior. It just depends on which way you see it. I see it like this. 1 and 3 are what kind of angles? They're vertical. So that means that angle 3 is 85 degrees. And what do you remember about same side interior angles? Starts with an S. Same side interior. S begins what other big word? Supplementary. So then we can set up our problem. So we have 2x minus 17, that's our angle 4, plus 85 degrees is equal to 180 degrees. Okay? So now we can combine like terms. Negative 17 and positive 85. So 10 away from 85 is 75. Take away 5, that's 70. Take away 2 more, that's 68. 68 plus 2x. If you don't know how I did that, little number sense. Equal to 180. I'm going to subtract 68 when I move it to the other side. So I have 2x equal to 2, 1, 1. 11, 12. 1, 12. I think I did that right. Then I divide by 2. So x is equal to 56. 56. That's not 56 degrees. That's just 56. Okay? And that's all we want. What is x? X is 56. Okay? Sort of easy? And it gets a little harder. Oh, I know you wanted to hear that. I know. Well, it just depends on if you know your angle relationships. You have to know your angle relationships. Okay, so let's do another one. Number 2. Find y if the measure of angle 3 is equal to 4y plus 30, and the measure of angle 7 equals 7y plus 6. It's a little bit harder. Let's fill in what we know. Okay. We know that angle 3, this angle right here, is 4y plus 30. 4y plus 30. And we know 7 is 7y plus 6, this one right here. 7y plus 6. Now, what kind of relationship do we have going on? In my previous years, I've taught this. I told my students for the interiors, look for the z. Find the z. Anything in the angles of z are congruent. So if I look for the z, I see that 4y plus 30 and 7y plus 6 are in the z, inside the z. So that means that they are congruent. Well, it means that they're equal. So I'm going to say that measure of angle 3 equals measure of angle 7, which means that 4y plus 30 degrees equals 7y plus 6 degrees. But how can we do that? It's a matter of solving equations. Remember the don't call me after midnight. DCMAM. Okay, distribute, we don't have any. Combine like terms, we don't have any. Move a variable, we need to do that. I'm going to move from left to right because I'm going from small to big. So then I have 3y plus 6 equal to 30. So now I did my move. Add or subtract. I'm going to move my 6 to the left, and I'm going to subtract 6. So that would be 24 equal to 3y. So I've added. Next, I'm going to multiply and divide. I'm going to divide by 3, divide by 3, so y equals 8. And that's what we needed to find. Not so hard, right? Okay. Let's try one more problem. Or one more pair. Let me change pages here. Let me draw a new picture. I have this set of parallel lines cut by this transversal. And how do I know they're parallel? Because the little markings are on them. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Number 3, if the measure of angle 2 equals 4x plus 7, and the measure of angle 7 equals 5x plus 13, find x. Let's figure out what we know. Angle 2 is right here, and it is 4x plus 7. 4x plus 7. Angle 7 is up here, and it's 5x plus 13. Oh boy, what can we do with this problem? Well, I see this is on the outside and this one's on the outside. They're on opposite sides. They're on alternate sides. They're both on the outside, the exterior, and they're opposite sides. I have alternate exterior angles. What do I know about alternate exterior angles? They're congruent. That means they equal each other. So I have 4x plus 7 equal to 5x plus 13. I'm going to move the 4x over here, make that 1x plus 13 equal to 7. I'm going to move the 13 over here, and that's going to be 13, that's a negative 4. So x equal negative 4. Oops, that was supposed to be a minus, but that's okay. We still worked it. Okay, number 4. Find y if measure of angle 3 or 5. Measure of angle 5. Let me rewrite that. 5 equals 68. And measure of angle 3 equals 3x minus 2, or 3y minus 2. Okay, let me erase the markings. Okay, so here we have angle 5, which is right here on the inside, and angle 3 on the inside. So angle 5 is 68. Angle 3 is 3y minus 2. 3y minus 2. What do I know about same side interior? Starts with an S. Same side interior means what? They are supplementary. They add together to make 180. So I'm going to start off with 3y minus 2 plus 68 equal to what number? 180. Okay. I'm going to combine my like terms, my negative 2 and my 68. Once again, DCMAM. I don't have any distributes. I don't have any combines. I don't have any moves. Oh, I do have combines. I forgot about that. Combine my like terms. 68 minus 2 is 66 plus 3y equal to 180. I'm going to subtract 66, so that would be a 4. 7 minus 6 is a 1, and bring down the 1 equal to 3y. Then I can divide and multiply, divide by 3, divide by 3. So y is equal to, see, 3, carry the 2, 38. And that's what I needed. So here was one answer. Here's the other answer. Okay? So now you can go have fun with equations. Have a good day.